Lesson 1, Introduction to Polynomials. The way we write numbers in our system is interesting because we only deal with our 10 digits, our 0 through 9. And we're able to write any number we'd like. This is because what we really are doing is counting how many powers of 10 that we have. Okay, powers of 10, dealing with some exponents here. So the first example says, write each of the following numbers as the sum of multiples of powers of 10. The first one is done as an example. So I'll let you guys look over example A, and I'm going to do example C right now. So if I sit and look at that, I say that that's 3,842. So what does that mean? Okay, think back to elementary school, okay, because you did this stuff. 3,000 plus 800 plus 40 plus 2. Okay, so I just expanded that. Now if I want to take that one step further, I could say really this is 3 times 1,000. I have 3,000 plus 8 times 100, because I have 800 plus 40, which is 4 tens, 4 times 10, plus 2, and if I really want to get down to that, 2 1, how could I write it? I could say a power of 10. I'll get to that in just a second in my next step. So it's a 2 times 1 there on the end. So let's go one more step further and write these as powers of 10. So I would say, okay, I have 3, and 1,000 as a power of 10 is 10 to the third. You type in 10 to the third in your calculator, you would get 1,000 plus 8 times 100 is 10 squared plus 4 times, that's 10 to the first, really, right? Plus 2, and if we continue this pattern, really there's a 10 to the 0 power there. We don't need to write it because it's understood, because anything to the 0 power is just 1. So I took, okay, my 3,842, I expanded it, and then I was able to write it as a power of 10. It's dealing with the place values there. So why are we talking about something like this? Okay, this is going to lead us into polynomials, right? So again, make sure that you go back and read through, walk through question A there. I would love for you to come to class with B and E done, okay? So you can use A and C as your examples. We can now use algebra to replace the base of 10, okay? So algebra, now we bring in our letters in here. So we're going to use our generic base of x. X seems to be the popular one, okay? Or obviously it says whatever variable you like. It says consider the number 63,735. As we did in example 1, write this number as the sum of multiples of powers of 10. So we take and we can say, all right, 60,000, right, plus 3,000, okay, right there. Now I've got 700 plus 30 plus 5. Now I'm going to take it one more step, and I'm going to say, okay, this is 60 times 10,000 plus 3 times 1,000 plus 7 times 100 plus 30 times 10 plus 5. Now let's write it as the sum of powers of 10. So it's 6 times 10,000, okay, is 10 to the 4th power, plus 3 times 1,000 is 10 to the 3rd power, plus 7 times 10 to the 2nd. What's happening with the exponents? Notice what's happening with the exponents as we continue on to the right. Plus 3 times 10 to the 1st, plus by 5. So if we take it the one more step, and now let's make it algebra, it says if x equals 10. Write this number, okay, this number that we just got done working with, our final answer, in terms of an equivalent, okay, an equal expression involving x. So my problem says here, right there, x is equal to 10. So let's take our final answer and substitute x in wherever we see 10. So we get 6x to the 4th power. Notice what I'm doing. I'm going right from here, okay? I'm going to erase that because that's going to get in front of my next problem. Plus 3x to the 3rd power plus 7x to the 2nd power plus 3x plus 5. So I took something that you are familiar with, okay, a basic number, 63,735. We took and we expanded it, we wrote it as a power of 10, and then, okay, we had a game changer. We brought in algebra, so we brought in some letters. Now we have a polynomial. So that's kind of how they are related. It says the base of a polynomial certainly doesn't have 10, okay, but all polynomials have a form similar to your answer in letter B. So let's define them a little bit more formally. So polynomial expressions, okay, we're not dealing with equations yet, just expressions. Any expression of this form, okay? So it says ax to the n is any exponent, plus b, some other coefficient, x to the n minus 1, plus c, x to the n minus 2. Notice that our exponents are always decreasing, and then it ends with a constant. I always try to call that constant with caboose. The caboose of a train is always the end of the train. So it says where these are the exponents, as they continue, are all positive integers. That's key, right? Note that not all powers need to be present because the coefficients, the a, the b, and the c, can be 0. So let's see, let's play around with some examples. It says, of the expressions shown below, circle all of them that represent polynomials. So they've got to fit our definition. Discuss why the ones that aren't polynomials fail the definition above. Okay? So right here, I'm going to examine the first one. So I've got 4x squared plus 8x plus 1. Do we have our exponents? Are they positive integers? So I have an exponent of 2, I have an exponent of 1, meaning I don't have any negative exponents. Not all powers need to be present. We do have our coefficients, our 4, our 8, and our 1. So that one is definitely a polynomial. When I look at this one, okay, my second one here, I'm kind of drawn to this guy right here. How could I write 1 over x a different way, an equivalent way? 9x squared, think back to our past chapter, plus I could see that's x to the negative 1. That right there, those two are equivalent. Now, does it fit our definition of having all positive integers? Nope. That guy, that one right there is not a polynomial. My next one in line here, all of my exponents are x's. What do we know about x? X could be anything. Okay, so we don't know in this case if x is a positive integer. So not a polynomial. And then this last one, okay, all basing on those exponents. We've got a 2, a 3, there's an exponent there of 1. Yep, this one's good to go. Go ahead, flip the page. So it says it is often important to place polynomials in standard form. Standard form of a polynomial is simply achieved by writing it is an equivalent expression, it's the same expression, where the exponents always descend. So if I take this first example, I need to find the term with the highest exponent. He's the leader, okay? He's the line leader. And then decrease my exponents from there. So now I would say, okay, the 3x squared is going to come next. and then my negative 8x, because that's a power of 1, and I end with my caboose. Okay? I'm going to have you do B and C. Let's just put them in standard form. Polynomials are simply abstract, okay, representations of numbers that we see every day, and they behave like numbers as well, which is pretty cool. Let's look at adding polynomials together. So it says, consider the numbers 523 and 271. Write each of them as the sum of multiples of powers of 10 as previously done on the first page. So if I take 523, I could say it's 500 plus 20 plus 3. And then I could further say it's 5 times 100 plus 2 times 10 plus 3, which is then, I have to write it over here to the side, 5 times 10 squared plus 2 times 10 plus 3. So I'm going to kind of put that one aside just for a second. I'm going to pause and shift some things over. Okay, let's do the same thing with the 271, right? So I'm going to change colors here for the 271. So it's 200 plus 70 plus 1, which is then 2 times 100 plus 7 times 10 plus 1, which is 2 times 10 squared plus 7 times 10 to the first plus 1. I'm going to line these up, okay? Because this is going to help me over here for letter B. So let's line them up vertically, okay? This guy and that guy, because they're asking us about our powers of 10. So 5 times 10 to the second plus 2 times 10 plus 3. And I'm going to line up my place values. Okay, you were taught that in elementary school. Okay, we can even put a 1 with each of those. Plus 1 when you were adding multiple digit numbers. So now when I say to myself, I take a look at this, I say, okay, how many 1s do I have? I have 4 1s. And then how many 10s do I have? I have 9 10s. And then how many hundreds do I have? I have 7 hundreds. So now, what's my answer? If I were to add these two up the traditional way, okay, I would end up with 794. 7 times 10 squared is 700. 9 times 10 to the first is 90 plus 4. 794, right, is the sum of that. We just kind of took that idea and played around with some numbers and some polynomials, which is kind of cool. Okay? So now, let's just go right to it. So it's just combining like terms now. Combining like terms is the same thing as adding the same place values. So what do we have? We have 7x squared plus 9x's plus 4. Okay, I'm going to have you do B and bring that to class. So we can subtract them as well. So I'm going to have you do B on your own. We're going to subtract letter A. So keep in mind, so it says find the difference. That's what told me I have to do some subtraction here. So let's think for a second. Oh, the subtraction sign. I think that subtraction sign is already there for us. That's the subtraction. Okay. I don't love the way that one is particularly written, but that's the subtraction sign of the whole problem. So what is 6x squared minus 2x squared? We know that that's 4x squared. So now be careful now with the x's. We have 5x minus a minus 4x because we're subtracting. You've got to go through that minus sign, it's like the gatekeeper. 5x minus a minus 4x really becomes 9x. So that minus and minus becomes plus. And now you have 3 minus 7, which is negative 4. It's difficult when it's written vertically. By all means, go ahead and do letter B. It's written horizontally. That's what we're used to. And when you're subtracting, what are we really doing? We're just distributing a negative 1. I'm going to have you come to class with B done And this next one is write an equivalent polynomial in standard, simplest standard form. It means combine like terms. So I start out with my highest exponent and combine. So 5x squared, and then my x's, okay, because that's my x to the first, plus 6x, we're putting in standard form. And then bring up the caboose there, minus 4. All right, come to class with those problems down that are circled and ready to answer some questions.